Improper integrals part 1. An improper integral is one that has infinity for a limit or that integrates up to a vertical asymptote. In this part, we will find integrals that have infinity for a limit. For example, suppose we have the function f of x equals 1 over x, and we want to integrate from 1 to infinity of f of x. A representation of the area is shown in the graph to the left. Essentially, we just do what we normally do when we have definite integrals. But we have to do a technicality. Since we can't really equal infinity, we start by rewriting the problem as the limit as b goes to infinity of 1 to b of 1 over x dx. B is arbitrary. You can choose whatever letter that you like, but we need to have this limit. Then we can find the antiderivative as normal, but we need to continue on with this limit as b goes to infinity out front of the natural log of x from 1 to b. No absolute values are needed around the x because we have positive values. And somewhere along the line, we need to plug in b is infinity, quote unquote equals infinity. Depending on your professor, maybe you can put down infinity. I recommend that you don't actually write it out in your paper, but in your mind, think b equals infinity. So I can have the natural log of infinity, which is infinity, minus the natural log of 1, which is 0. So if I were to integrate from 1 to infinity, the area beneath the curve and above the x-axis would equal infinity. Now the question might arise, if I integrate from 1 to infinity of any function, as long as it's a non-zero function, won't the value always equal infinity? Let's take a look at our next example. And let's integrate g of x from 1 to infinity, where g of x equals 1 over x squared. It's a similar graph as the one above. I didn't draw it to scale, but just to give a representation. We're going to evaluate this integral, starting by doing the limit as b goes to infinity of 1 to b of 1 over x squared dx. That will give us the area beneath the curve. We will rewrite limit as b goes to infinity, but we will find the antiderivative using our power rule from 1 to b. Now I know that b, quote unquote, equals infinity. I'm going to plug it in my mind, so I have negative 1 over infinity, which is really, really close to 0. So we'll put down 0 minus negative 1 over 1. And this equals 1. So in this case, we integrated from 1 to infinity, but we got a finite answer. Very briefly, I have a couple definitions for you. We say that an integral converges if the sum is unique and finite. We'll concentrate on the finite here. Otherwise, the integral diverges. Since in our first example, the value went to infinity, we would say that this integral diverges. But in the second example, the integral equaled 1. And we would say that the integral converges. In the next part, we're going to look at integrals of the form 1 to infinity of 1 over x to the p, where p is a constant, to determine when will this integral converge and when will it diverge.